Good morning, everybody. In this chapter, we will focus on hypothesis testing for a single sample. And once again, much of this notes is based from Montgomery and Runger, Mendenhall, Schaefer and Wackerly, and J. DeVore. What we'll focus on is how do we test statistical hypotheses for a single sample. And in the next chapter, we'll talk about hypothesis testing for two samples. And this chapter is once again divided into four or five modules. Module 1 will focus on testing on mean of normal distribution when the variance is known. The second module will test the mean of normal distribution with a variance unknown, just like the last chapter. Then we'll go to tests on variance and standard deviation of normal distribution, and then we'll go to testing hypotheses for population proportion, and then we'll briefly talk about goodness of fit for a distribution, and we'll also talk about some non-parametric procedures. And so what we'll do is we'll begin today's discussion with module number 1, which is test of means of a normal distribution when the variance is known, just like the confidence interval chapter. So this chapter really marks the beginning of this course. The previous material is really intended, while I'll be testing you on that, it is intended for for the sake of revision, just to kind of get you guys up to speed. But this is where the real material begins, and after this we will go into two sample hypothesis testing. We'll go to simple linear regression, we'll go to multiple linear regression, and we'll go to logistic regression, Poisson regression, and if we have time we'll get into some quality control and design of experiments. So that'll be the plan for the semester. So let's begin now with hypothesis testing for one sample. First, let's talk about what is a hypothesis. If you recall, previously we talked about how we can compute confidence intervals for a population parameter called mu, right? In this chapter, what we'll do is we will test hypotheses about a sample of data, just like what we did last time. We want to draw inferences about a population using a sample, because you will never have the entire population with you. You'll always have a sample. So we'll use these sample throughout this course to make decisions about the entire population. So hypothesis testing is very useful when decision makers are interested in comparing the mean of a population to a standard value. So, and this is really one of the most commonly used statistical tests or procedures. So hypothesis is really a statement about the parameters of one or more populations. So bear in mind when we are talking about this, all of this, applied statistical analysis does not really differ much between undergraduate stuff and graduate material. All we'll do is we will solve much larger problems. We'll get into a theory a lot more, and we'll use some real life examples as much as we can, and we will use software. That way you can get the necessary skills to use it in your work, or when you're doing research for your theses or dissertations. So let's take an example, and we'll kind of stick with the same example throughout the chapter, or throughout this at least throughout this module, to kind of get us going. So let's talk about an engineer who's testing the burning rate of a solid propellant in an airplane ejection system, the seat ejection system. So this engineer is testing the burning rate of the solid propellant in this airplane ejection system, and he has a hypothesis about this burning rate. Say if you're interested in the burning rate of the propellant being 50 centimeters per second or not. So we call this a hypothesis, because he or she is making a hypothesis about the burning rate of this solid propellant. So formally this is how it is expressed. So H naught is mu equals 50 centimeters per second. This is called the null hypothesis, where you're saying that the solid propellant burns at a rate of 50 centimeters per second. And the alternative hypothesis, or the research hypothesis, is where you're saying the mu, or the population mean, is not equal to 50. So this statement is what we call in statistics as a two-sided alternative hypothesis, because it doesn't matter which side it falls. All you're really testing is that this hypothesis is different, or this burning rate is different than 50. You don't care whether it's higher or lower. So that's the reason it's called a two-sided alternative hypothesis. So the analyst is really interested in simply proving that the propellant burning rate is just different than 50 centimeters per second. So maybe if it is different, if it is significantly different, and we'll talk about that in a second, but if it is significantly different, you might have to reject the hypothesis that you have made. So your null hypothesis is always designated by H naught, and your alternative hypothesis is designated as H1. And let's now talk about one-sided hypothesis. For example, if the analyst is interested in proving if the propellant burning rate is either higher or lower. For example, maybe if the propellant burning rate is higher, then there may be some eventualities, and the same may be the case if the burning rate is lower. So in that case, we can use what is known as a one-sided alternative hypothesis. So framing of the hypothesis really depends on the question that you're trying to answer. So the way we state this is as follows. So we'll say that H naught, that won't change. You're still saying that your null hypothesis is that, let's say, this company that is producing this solid propellant is saying that hey, we are supplying this material and the solid propellant has a burning rate of 50 centimeter per second, and you're actually trying to test, let's say you have a feeling that maybe this solid propellant burns at a rate higher, and that might cause some issues with the ejection system. Or there may be another hypothesis where you might say that no, there's not burning as quickly, and it does not eject in time, and may cause injury to the pilot who's getting ejected out of the cockpit. And similarly, when it ejects too fast, there may be a problem. So these are called one-sided alternative hypothesis. So once again, H1, so all you have is H naught, mu equals 50 centimeters per second, which is your null hypothesis. And you have H1 where mu is greater than 50 centimeter per second, or H1 where mu is less than 50 centimeter per second. So this is how you state a one-sided alternative hypothesis. You have to bear in mind that hypotheses are always made about populations under study. So you cannot really make a hypothesis about a sample. You're always making hypotheses about populations that you're trying to study. So for example, in the previous case, we talked about the mean, or the mu, being 50. So how does one determine this 50? Right? If you're wondering how we came up with this 50, or how this engineer came up with this 50, so technically there are about three ways to do this. One could be based on past experience. Maybe in the past, vendors, when they supplied the solid propellant, had a burning rate of 50 centimeter per second, and maybe that's a standard that these guys require, or these are really the design specifications. That could be another way to do it. Or this could be an output of a model under study. So there could be three different ways of producing it. So in our case, it appears that the most appropriate for this example could be, these are the design specifications that for this particular ejection system, this airline company really requires, the military really requires, that this mu has to be 50 and not significantly different from 50. Sometimes that value may be determined as an output. Sometimes it may be based on past experience. If you don't have a number 2 and number 3, it may be determined based on experience. So whatever may be the case, in this chapter we will assume that we all know this quantity, but in your project this is something that you'll have to think about, right? So this, as you're as we go move forward in this course, you'll be required to do an individual project, each one of you, and this is something that you have to think about. Maybe if you're doing a company from I'm sorry, if you're doing a project with the company, you have to talk to the managers or people on the floor about about the problem that you're trying to tackle, and you might have to get this value, whatever this value might be, and whatever you're trying to test. Or if you're working on a research project, then you might have to talk to your advisor, or talk to professors in the department to see what may be a proper value, what might be a good value to test your hypothesis against. So these are things that you'll have to bear in mind when doing hypothesis testing. Now let's talk about the types of errors that are committed by people when you're testing hypotheses. The first one is called the type 1 error. So the type 1 error is you're rejecting the null hypothesis H naught when in fact it is true, and that is represented by alpha, and it is a probability of rejecting H naught when H naught is in fact true. Type 2 error happens when you fail to reject the null hypothesis H naught when it is false, or in other words, you're accepting when it is false. So that is represented by the letter beta. This is also called type 1 error is called alpha error, and type 2 error is called the beta error. Statistically speaking, you really never accept a hypothesis. You always fail to reject the hypothesis. Now, that's really called beating around the bush. Okay, because in statistics, you never say that I'm accepting this hypothesis. You just say that we do not have enough evidence to reject this hypothesis. That is how it is stated. Now, let's quickly talk about what the power of a test is, and then we'll solve some examples. So, power of a test is the probability of correctly rejecting a false hypothesis. It is the probability, so listen to this carefully. It is a probability of correctly rejecting a false hypothesis, which means you want the power to be as high as possible. This is really the sensitivity of your test. So you want this power to be as high as possible. That way you're correctly rejecting any false hypothesis. So we'll also talk about what is known as the Neyman-Pearson's lemma, and this method. So these are two statisticians, Neyman and Pearson, and they developed a mechanism using which you can develop the most powerful test. When you're testing a hypothesis, there is a mechanism using which you can develop the most powerful test, and we'll briefly cover the Neyman-Pearson lemma towards the end of this module. Just to quickly summarize decisions and errors. So if your H naught is true and you fail to reject H naught, then there is no error. So we are okay. But if your H naught is true and you're rejecting H naught, you're committing what is called a type 1 error, like we just talked about. And if the H naught is false but you fail to reject H naught, then you're committing what is called a type 2 error, or the beta error. Type 1 error is called the alpha error. But if the H naught is false and if you're rejecting H naught, then you're committing no error. So there are two ways in which you can commit these errors. So what we'll do is let's take an example, and we'll solve for alpha error, the beta error, and the power of a test to understand these things clearly.